50 white marbles, 50 black marbles, and 2 empty jars. Every marble has to go into a jar, and you are the one who decides which. 25 and 25 in each. All the white ones together. One marble sitting on its own. Anything you like, as long as neither jar ends up empty. Then you hand them over, and you stop being in charge. Someone else flips a coin to choose a jar, and they have no idea what is inside either one. They reach into the jar the coin picked, without looking, and take out a single marble. You win if that marble comes out white. So the entire game is what you did with the 100 marbles before you let go of them. And here is the size of it. The arrangement almost everyone reaches for leaves you on a coin flip. Exactly 1/2. The best arrangement gets you near 3/4. Same marbles, same coin. And when you see it, it looks like a mistake. Start where everyone starts. 25 white and 25 black in one jar, and the same in the other. Look at what that pays you. Whichever jar the coin picks, it holds 50 marbles, and 25 of them are white. So the draw is a coin flip inside a coin flip. Exactly 1/2. The arithmetic there is fine. What is wrong is the thought that comes after it, which is that 1/2 is what this problem is worth. So try the opposite. Every white marble in the left jar, every black marble in the right. Half the time the coin picks the left jar and you draw white for certain. Half the time it picks the right and you cannot draw white at all. 1/2 again. And it keeps happening. 9 white and 9 black in a jar. 40 and 40. 1 and 1. Every one of those arrangements returns the very same number. So the even split is not one unlucky choice. It is a whole family of choices that all land in the same place. And something is putting them there. That is the thing worth finding. Two things happen here, one after the other, and only one of them belongs to you. First, the jar gets chosen. That is the coin, and nothing you do with the marbles can bend it. Half the time the left jar, half the time the right. Then a marble comes out of whichever jar showed up, and that part is entirely your doing. It is however much white you put in there. So write down what the chance of white really is. Take the share of white in the left jar, take the share of white in the right jar. Add the two and cut the total in half. That is the whole formula. People call it the law of total probability, though the name does less work than the picture does. Two numbers averaged with the same weight on each. Now put the even split back through it. The left jar is 1/2 white, the right jar is 1/2 white, and the average of 1/2 and 1/2 is 1/2. Of course it is. And you can see the trap from here. The two weights are locked. You cannot make the coin lean towards your good jar because the coin has never seen the jars. What you can change is the two numbers being averaged. That is the only thing on the table. Notice what just happened, because that was the actual skill. The problem handed you two moving parts, and one of them was never yours. Finding that line, before any arithmetic at all, is most of the work. I have coached hundreds of people through these interviews, and for some of them it ended in the seat they were aiming at, north of $500,000 a year. They are not faster with fractions than anybody else. They spend the first 30 seconds working out what is fixed and what is free. That is what the Quant interview playbook is built around. 411 pages, 4 tracks, and solutions that name the move before they touch the algebra. Link is in the description. Now back to those two numbers. You are buying two numbers with 100 marbles. Both of them are shares of white, so neither one can go above 1. So buy 1. A jar with nothing in it but white marbles hands you white every single time. That branch is finished, and it is worth its full half of the answer. But nothing here is free. Every white marble you lock away in that jar is a white marble the other jar no longer has. And the other jar is where you land the other half of the time. So how big should the certain jar be? Try 10 white marbles alone in the left jar. It pays white for certain. The right jar is then holding 40 white and 50 black, 90 marbles in all, so it runs at 40 in 90. Average those two, about 72%, already a long way past a half. Now take a marble back. Move one white marble out of the small jar and into the big one. The small jar is still nothing but white, so its number does not move at all. It was already 1, and 1 is where it stays. The big jar has just gained a white marble, so its number goes up, which means the answer goes up. And you can do that again, and again, until there is a single marble left in that jar. One white marble, alone. That is the arrangement. So here it is, whole. One white marble in the left jar, on its own. The other 99 in the right jar, which is 49 white, and all 50 black. Half the time, the coin picks the left jar, and it is white, guaranteed. Half of 1 is 1/2. Half the time it picks the right, and there you are, drawing from 99 marbles, of which 49 are white. 49 in 99. Just under a half, and it cost you almost nothing, because taking one white marble out of 100 barely moves that ratio. Add the two pieces together. 74 in 99, which is 0.74. 74. And those two digits go on repeating forever. Nearly 75%. Set that beside the 1/2 you started with. You have picked up an extra 49 parts in 198, near enough a quarter of the whole thing, and the only difference between the two arrangements is where one marble is sitting. Better than a half is not the same as best, so let us settle it. Fix the size of the smaller jar first, and only ask what goes in it. Say it holds 7 marbles. Swap a black marble in that jar for a white one from the other side. The small jar has 7 marbles, so its share of white climbs by a 7th. The big jar has 93, so its share falls by a 93rd. A 7th is far bigger than a 93rd, and the two jars carry equal weight in the average, so you have gained. That works at every size below 50. Whatever the small jar holds, fill it with white. Then shrink it. With an all-white small jar, going from 1 marble to 2 costs you, 2 to 3 costs you again, and there is a loss at every single step. So the smallest possible jar wins, and the smallest possible jar holds 1 marble. That is the argument. We also just checked, because checking is cheap. There are 2,599 legal ways to put 100 marbles into 2 jars. Every one of them was worked out in exact fractions. The largest is 74 in 99, and exactly one arrangement reaches it. One last thing worth knowing. It never gets to 3/4. 74 in 99 falls short by 1 part in 396. Play the same game with 1,000 of each, and you get closer. 1,000,000, closer still. 3/4 is the ceiling, and nobody ever arrives, because that one lonely marble always has to come from somewhere. Step back from the marbles for a moment. The problem looked like it was about 100 objects, and it was really about 2 numbers. One of them you could push all the way to certainty. The other one you were going to damage as little as possible while you did it. Everything else was decoration. And the reason an even split feels right is that it feels fair. Fairness is a good instinct almost everywhere, and a bad one here, because the coin is already doing the fair part, and it is doing it whatever you decide. Being fair twice over just averages 2 identical numbers. Now, the part that matters if you are sitting in one of these rooms. The answer here is 1 sentence long. 1 white marble on its own. Anyone can memorize that. What gets written down while you talk is whether you found the fixed part before you started calculating, and whether you could say why nothing beats it instead of simply asserting it. 15 years of hiring in finance taught me that the sheet in front of the interviewer has almost nothing on it about your final number. The Quant interview playbook is where I put all of it. 4 annotated mock interviews with that scoring running down the margin. 1-pagers on 24 desks. An 8-week plan and a 12-week plan, day by day, so you run the one that matches the weeks you actually have. Link is in the description, and I would go and get it before your next batch of applications goes out. 50 white, 50 black, and 1 marble on its own.